Hello there, and welcome to one of my past paper walkthrough tutorials or walkthroughs. So this time, this is the moment all of us have been waiting for, particularly for those who have sat their computer science exam in the year 2023 for the OCR syllabus. For those of you who were victim of that, really sorry about that. So this was the paper in which some people felt that OCR did not want you to see, but thank goodness it's actually out. So for those who actually sat this paper, will remember how awful this paper 2 was. So have a look. Um, so what? So basically, it was awful. I've heard a lot about it. So let's have a look at the paper. So we're gonna in this video, we're gonna have a look at the paper that we all thought OCR was reluctant to release or didn't actually want to release because it's so damn hard. So if you want to pass, watch this video, because if you can do this one, you can do any, and say Bosh-tastic. Okay, but before I do, please remember to click that like and subscribe button, and write a comment in the comment section down below, and also share this video far and wide, especially if you want your peers to pass or don't want the full victim like you did like those who sat in 2023 did in that paper. Let's go. Yep, I'm not going to go for the la-di-da. Yeah, you don't use a calculator. Yeah, pity, but life must go on. Question 1. So, a table contains 4 statements about programming languages. So we're going to tick a box, which will identify whether each statement describes a low-level or high-level programming language. Same language can be used on computers that use different hardware. That's a high-level language. Let's have a look at this statement. It allows the user to directly manipulate memory. That's going to be low level because you're working with the hardware and you're also in device driver level as well. So all of that is low level. It allows the user to write English-like words. If you have done Python, that's the closest in programming languages you're going to get to English. So that is and Python's a high-level language. It always needs to be translated into object code or machine code. That's high level, right there. Okay, so what we should have is tick in the first statement in high level, second statement tick low level, third and fourth tick tick high level. If you do that, that's 4 marks in the bag. Bosh. Next question. The variables num1 and num2, they store integers. So we need to write pseudocode that will add them together. And we have to store the result with the identifier total. So this is how we would actually do it. So we would actually do total equals num1 plus num2. So the identifier is total, and the 2 variables are num1 and num2, and we're adding them together, and we have to use the plus arithmetic operator. The equals, we are assigning 2 values to be added to the total variable, or the identifier. Right, we've got 3 incomplete pseudocode algorithms given with a description of the purpose of each algorithm. So we're going to write the missing arithmetic operator going on here. So we need a missing. Outputting 12 to the power of 2. So if we're going to do that, outputting 12 to the power of 2, that's going to be that little symbol. That is to show to the power of. If you're wondering how to get this button on a computer, you're literally pressing Shift and 6. So that's 1 mark. Let's say we want to work out whether the number is odd or even. Process of elimination. It's not going to be plus, it's not going to be minus, it's not going to be in basics. It's actually going to be mod. if you've written in Python, then you'll likely have come across the percent. The percent still means modulus. Okay, so whichever one, they'll accept percent if you put percent down, or mod. But mod is the ideal answer that they're looking for. Okay, so you'd have mod or percent, doesn't matter. Okay, let's find the difference between two measurements. Measurement 1 equals 300. Measurement 2, a variable which we've assigned the value of 100. So the difference, for those of you in maths, difference is biggest takeaway smallest. So in this one, they're looking for subtraction. That's what they're looking for, is subtraction. Okay? And then part D, we need to read the following pseudocode algorithm. So start is equal to 3. Then we got do until, which if you're averse for C# or Java or C++, that will be a do while loop. So we're printing the start, and then we're decrementing the start. And then once we get to -1, that's when we finish the code. So we need to complete the following trace table. So that, I think, is what put a lot of people off. And I wouldn't be surprised if that were the case. So let's look at line number 1. We're starting at 3. And then once we get to line 3, we're just outputting 3. Okay? Let's get to line 4, which is a decrement. So 3 take away 1 is 2. So we're back on line 3, and the output is going to be a 2. And then we're back on line 4. We're taking that away, and that's going down to 1. And then what we're doing, we're going onto line 3. We're just going to go output 1. Then we're back on line 4, which is going to be a 0. And then we're on line 3, which is 0, which is also going to be a 0. And then we're on line 4. And at the start, 0 take away 1 is going to be -1. So as the start is equal to -1, that is finished. So the idea is, it's tracing the number. The idea is for this loop to decrement a number by 1 each time until the start is equal to -1. And because the start is now equal to -1, we come out of the loop. And -1 should not have been outputted in this case. You just need to say, once we get to -1, we just print finished. And a finish goes in the output. Okay? Right, let's try another one. Question 2. The pseudocode algorithm totals all the numbers in the 0 indexed array scores. So this is the 0 indexed array scores, and it's having the score count, which is the index. So we're going from 1 to scores length -1. So the function length, it's going to return the number of elements in the array. The algorithm has several errors. So syntax and logic errors are the 2 types, which they've given you. So we're basically saying, what's a syntax error? What's a logic error? Syntax error is errors in the rules based on the programming language that you're using. So for example, If in Python you wanted to do a print statement and you just did that, that is not going to work. That is a syntax error, meaning, and the reason why that's a syntax error because the P is a capital when the special word is actually starts with a lowercase p. So that's a syntax error because that is a rule. So the rule is it has to be lowercase. So a syntax error is an error in the rules of that programming language. Okay? Logic errors, the program works, but the result, the output, is going to be incorrect. Okay, so it's not just incorrect, so it's going to produce the incorrect result. So let's say, for example, I wanted to do a program. Answer, let's say num1 plus num2 minus num3 times num4 divided by num5. So you would think, okay, num1 is 4, num2 is 2, 6, take away 1 is 5, times, say, num4, 2, 10, divide by 2, 5. You would think by doing that, you're going to get 5. Wrong. Why? Because programming languages, they follow the rules of bitmass. Multiplication, or division, multiplication, addition, subtraction. Before that, you have the brackets and indices. Okay? So that's why that order, it won't actually work it out in that order that you see on your screen. What they're actually going to do is they're going to do num4 divided by num5 possibly times num3 and I would say plus num2 or plus num1 minus num2. Or if I had to do it, I'd probably say 1 plus 2 minus 3. So you're likely to get it in this order instead, because we're doing the rules of bitmass. So that's where the logic error, that is why on the first one you would get a logic error. So logic error produces something, but it's not correct. So now, next one, we need to identify 2 logic errors in the pseudocode. So we need to identify a line number and a corrected line. So the first one's on line 2. So what we should have had, it should not be equal to 1. That should be equal to 0. So we know it's line 02. So we should have had 4 score count is equal to 0 to scores length minus 1. And then second line number will actually be line 3. And what you could have had, total equals total plus scores score count. Now that will get you 4 marks. Okay? Number 3. Algorithms. An insertion sort is one type of sorting algorithm. So a student has got a pseudocode algorithm to perform an insertion sort on a 1D array called names. So based on this pseudocode, we need to describe the purpose of the variable temp. So in the insertion sort pseudocode algorithm. So what the temp variable is going to do, it will store the value during the time in which the value is changed and swapped. So that's what we want it to do. And the objective is we don't want it to be lost. Because if we don't have a temp variable and we want to change it, that data is going to be lost. That value will be lost. Okay? So that's why we have the temp variable. Because you want to change the value, but you don't want to lose it. B, an insertion sort contains a nested loop, so it's a loop in a loop. In the pseudocode algorithm, the outer loop is a count-controlled loop, which is your for, and the inner one is a condition-controlled loop. So, we need to explain why the inner loop needs to be a condition-controlled loop. Well, the reason why it needs to be that is because we don't actually know how many iterations will take place. That's what so that's what the while loop is. We don't know how many iterations we're going to have, how many times the value will change position. So that's one reason. And another reason is condition control loops. So while loops will run whilst the condition is true. Once it is false, the loop ends because the condition is false. So that is what condition controlled loops do. So condition controlled loop is your while loop. Count controlled loop is your for loop. Okay, and that's for any programming language. Okay. Then we got another sorting algorithm called a bubble sort. So a bubble sort algorithm is another sorting algorithm. So we need to describe one difference between an insertion sort and a bubble sort. So an insertion sort will move values into the correct position, whereas a bubble sort is going to compare pairs of values to see which is bigger. So that is literally it for that one. And then two similarities which we have to describe. So similarities is we can't just say they're both sorting algorithms. So both will produce a sorted list, hence clues in the name, sorting algorithm. And both will use loops. Yes, they will. And they will also use selection. They'll work with arrays, but some of them will only work with short arrays, some of them will work with long ones. Both may need lots of passes, and that's certainly the case with a lot of sorting algorithms, especially a quicksort. Quicksort is so many passes, but don't worry about quicksort. That's A-level stuff. Whereas a bubble sort, that's going to take lots and lots. That's going to take lots and lots of iterations. Four, we've got a garden floodlight system. It inputs from sensors and switches. to decide when it should be turned on. So we've got a table that shows the inputs into the system and the meaning of each input value. So we've got letter ABC, which are outputs. Input device is going to be your motion sensor, your light sensor, your light switch. Input of 1, motions detected, 0, not detected. 1, light levels indicate it's daytime, 0, light levels indicate it's nighttime. For input 1 on C, switches on, 0, switches off. So the floodlight Q is designated to be on Q equals 1. When the switch is turned on and the motion sensor details detect it's nighttime. So how are we going to actually do this? We've got to draw the logic diagram for that floodlight. So if we have a look, up here. So light sensor, daytime, nighttime. In B, we're going to have a NOT gate. Okay, it's a little funny circle. A is going to be an AND. That's going to be an AND gate. So there we go, A and B, that's done. And then C, we're just going to go all the way around up here. And as for this AND gate, we're just going to connect here. There's our AND gate. And then we're going up the Q. Okay, so we know the motion is detected and it's nighttime. So the floodlight is on. So we know A is going to be a 1. B, it's nighttime, so that's why we have a NOT gate. And then C, the light switch is turned on. So the only one that's basically on input 0 is B, because it's nighttime. Okay? And that's our logic gate for 3 marks. Okay? So B, we need to identify the logic gates for truth table 1 and truth table 2. If both inputs are a 0, the output's a 0. If any input has a 1, then the output's going to be a 1. And you'll find this with an OR gate. With this truth table, you'll see the only way the output is going to be a 1 is for both inputs to be a 1. Otherwise, everything else is just going to be zeros. And you'll find this in an AND gate. Let's move on. 5. Charlie is adding a game. He's developing an adding game. The rules of the game are: players ask 3 questions. Each question asks the player to add together 2 random whole numbers between 1 and 10 inclusive. If the player gets a correct answer, 1 is added to the score. At the end of the game, their score is displayed. So, Charlie's been told that the game will need to be tested before giving it to the players. So we need to explain why programs should be tested before use. Because we have to check that the program works and see if it actually meets user requirements. So I would say to check that the program works and also meets user requirements. That's a straight 2 marks right there. And yes, we also need to know if it's going to produce the correct result. And we also need to see if there's any bugs in our code. Meaning we'll have to debug our program. And some people we'll try and break the program with the intention of ultimately making it as error-free as possible. And thereby, by doing that, you can ensure that no problems arise when the game is actually released. Let's try this one. We need to complete the table by naming and describing one type of test that should be used on Charlie's program before releasing it. So I would opt for iterative testing, and the reason why I would say iterative is because games are nasty little things to do. And the reason why I say iterative, because we want to complete tests during development. So we could test it after, when each part is completed. So the reason why I would opt for iterative is because you can have some of your program working. If you try to do no test and get all of it working, you're going to end up all of it not working. You're better off having some of your code working than all of it not working. So what we need to do now is complete the table by identifying and describing two features of an IDE that can be used when testing a program. So one good one, important one, is a debugger, and a debugger is self-explanatory. It's going to debug, find any errors for us, the programmer, to actually address. Another one is the runtime environment. So runtime environment will allow the program to actually be executed, and it's going to show the output of the code that we have written. Next one. It's about validating inputs, which can reduce errors when a program is being run. So we need to identify two methods of validation and explain how they can be used in this game. So there's lots of different validation methods. Presence check, range check, type check, length check. So I would have a presence check, my personal favorite. So what a presence check is going to do is going to make sure that a value is inputted at all. So it means while there's nothing there, it's going to make you input something until you've inputted something. And then we're going to length check. That's good if you wanted to do like telephone numbers, where it cannot be, if you're in the UK, it cannot be, a phone number is 11 numbers. You can't go any more, you can't go any less. So what length check will do, it will limit how many characters are allowed to be entered. So let's say I want to do while phone num is not equal to 11. So in that, here I'm just going to make user enter phone number until the length of the phone number is 11. So that is how a length check would work. Okay? And then C, we got to write an algorithm to actually play the game. So this one's a 6 marker. So what do we need to do? Player is asked 3 addition questions. Each question asks the player to add together 2 random whole numbers between 1 and 10 inclusive. If a player gets the correct answer, 1's added to the score. At the end of the game, score's displayed. So let's break it down. So we want score, obviously. So you want score to be 0. So we got 3 additional questions. So we want count 1 to 3. And we want 2 numbers. So we're going to have num1, random 1 to 10, num2, random 1 to 10. And we want answer. I'm going to ask him to input what is num1 plus num2 okay. So we've got that bit. Now we want to find out if the player has the correct answer. So it's going to be if ans is num1 plus num2, then we want to have score, which will increment by 1. Obviously, we're going to end if, then we're going to go to the next count. So that's going to go up 3 times. And then now we want to print the score. So we're going to print, not yo scored, you scored. Why do I don't know why I'm in that bad habit of saying yo, but A. I think it's just habit. Some people say yo by mistake, but A. But nonetheless, that would get us a full 6 marks. Because, what have we got? We got our 3 questions. So we got a for loop going from 1 to 3. So in there, so we're going through those questions. So we're going through this block of code 3 times. So if the answer's right, that's going to go up. That score's going to increment, and we go back, increment, go back. But if you get an answer wrong, we obviously just go straight to the next count. So if the answer's incorrect, we just go to the next count from there. And once we've got the 3, it's going to come out of the loop and then just print out our final score. Okay? And that is 6 marks. Nice 6 marks. Last section of the god-awful paper that I've heard so much about. I feel sorry for people who have sat it. So, OCR security services. Yeah, what a name for it. So, company that installs intruder alarm systems in commercial buildings. Probably like their buildings for those who are trying to get this paper before release. The system uses a computer that's connected to the door sensors and window sensors. The following data is stored in the system. It's got all this data stored. We've got its variable identifiers. And we got the example data. So what we got to do is tick one box to identify the most appropriate data type for each variable. The door sensor active, that's Boolean. This is true or false. There are none with characters. Username, emergency phone number, they're strings. Door time's going to be an integer. And we've got nothing for decimal. How do I know that? Username, string, emergency phone, string, door sensor, Boolean. And then door time. So door active time. So timer that counts in every second how long a door sensor has been activated. So that's going to be like your door time. That's going to be 100. Okay? Done. For part B, the alarm has an algorithm that decides whether to sound the alarm by checking the data that is stored in the following 3 variables. System on, door sensor active, window sensor active. So the alarm will sound when the alarm has been activated and one or both the door windows sensors are activated. When the system needs to sound the alarm, it calls the pre-written procedure sound alarm. So we need to write a program that checks the data and variables and calls sound alarm when appropriate. So you're going to use OCR reference language, which is OCR pseudocode, or high-level language that you have studied. So I'm going to do pseudocode. So if system armed, then if door sensor active, then sound alarm, that's where we're calling the subroutine or the function. I'm going to do window sensor active, then that's going to call sound alarm. Then we're just going to end if, and we're going to end if. That's literally 4 marks in the bag. What you could do potentially, instead of having an if, because if will only do it once, you could have while in there instead. And the only difference with the while, it's going to keep doing it until the condition's false. Okay? But that would get you 4 marks also. Right, C. The alarm system can also have motion sensors. Each type of sensor has a code. The code for each sensor is given in the table. So MS is motion sensor, DS is door sensor, WS is window sensor. So programs written to reset those sensors. So the program asks users to enter the code for the sensor they want to reset. Call the pre-written function check sensor code to check whether the code entered is valid, and the sensor number is read as input if the code is valid, and the function reset sensor is called for the sensor. What have we got? Sensor type, again to input the type of sensor. If check sensor code is a sensor type, which is our parameter, ask them to input the sensor number, add type to sensor number to get the ID, then we get concatenate to get the ID. So we've got to give a line where there's concatenation. Line 4, we're concatenating 2 strings together. Give the identifier variable used in the program. Sensor type. Identify the data type that the data returned by the function check sensor code. That's Boolean. Is it there? Is it not there? Right. One of 2 outcomes. How's a politician not answer a question? Yes or no. So in this case, check sensor code. Is it true or is it false? Bosh, done. Right, give the line number that contains a function call. Line 2, check sensor code. That's one there. And there is none for line 3. And you got 1 for line 5. I can't see where you got 1 for lines 3 and 1. It's definitely there for line 2. And there's definitely 1 for line 5. So it's either line 2 or line 5. And then we need to identify 2 programming constructs that have been used in the program. So if we go up, selection's been used and sequencing has been used. So selection is your if statements. Sequencing is inputs, outputs, processes to get the outputs resulting from the 2 inputs that we've done. And D, the alarm system has a log that stores a record of each sensor that's been triggered. This is called an event, and the record format is given in the table. So the log is stored in a database called events, and the current contents of events is shown. So you've got your date, sensor ID, sensor type, and the length. So what we got to do is write an SQL statement. display the sensor IDs at the door sensors that's been triggered for more than 20 seconds. So the length is seconds. Select, and we want sensor ID, or you could have select everything from events. So I'm going to do asterisk and 8, select everything from events. Just doing those two will get you 2 marks straight there. And then I would have where length is greater than 20, because it's 20 seconds, but IDs of the door sensor, so just looking for door. And sensor type is going to equal to door. That is 3 marks in the bag. Literally 3 marks. Last one. This program is written in a high-level language used to access the data from the database. The program will have a procedure called save logs. Okay. So the procedure save logs will take a string of data that's to be stored in the text file as a parameter. Takes a file name of the text file as a parameter and stores a string of data to the text file. So we've got to write the procedure save logs. So we would do procedure save logs. In there we want data and we want the file name. They are our parameters. Then we want log file. So we're actually going to open the file name. And then what we're going to do, we're going to do log file, right line, and we're going to write data, which is also one of our parameters. Then we want to close the file to save the memory, and then we're just going to end procedure. And that will actually get you 6 marks, believe it or not. You have 1 mark for defining this procedure, 1 mark with the 2 parameters, 1 mark to open a file, 1 mark to use the file name as a parameter, 1 to write the data, 1 just for writing data in brackets as our parameter, and 1 mark just for closing the file. So you get 1 mark for this bit, 1 mark for this bit, you'll get 1 mark for this bit, 1 mark for this, you get 1 mark for this, 1 mark for this, 1 mark for this. 6 marks in the bag. I say, if we're doing something like that for 6 marks, that sounds fantastic. But hey, this was the paper that a lot of people found awful to do. But OCR, they never like to make things look easy, do they? Or any exam board for that matter. F. OCR security services need to identify the total number of seconds the sensors have been activated on a specific date. The data from the table events is imported into the program written in a high-level language. The program stores the data in a 2D array with the identifier array events. So in this table, we've got the value events 1, 1. So an array can only store data of one type. Any non-string data must be converted into a string before storing in the array. So identify the process that converts integer to strings. That's casting. That's literally casting. Yeah, and you would have done, that's one of the first things that I teach you to my students when starting out on a programming language, whether it be Python, Java, C# or C++. That's casting. And then we've got to write a program that asks the user to input a date, total number of seconds as sensors has been activated on the date input. Output the calculated total in the appropriate message, including the date, saying how long they were activated for and on what date. So, how are we going to do that? So, we need to work out the total. So, we need a total to be a 0. We need to get the user to input the date. And we want a loop that's going to increment that. So we want for count to be 0 to events length -1, so that means decrementing. Then we want if events 0 count is equal to date, then we want total to be total plus events 3 to count. Then we want to end if, and then we want the next count. And then what we're going to do here is we're just going to do a simple print statement, which looks like this. So we're printing that there are this many events on that date. Hence that. Hence we were doing that. Okay? And such a question like that is another 6 marker. Okay? So how would the mark thing work? Out of 6. You get 1 mark just for having a second line. And then you would have a mark for accessing all of the indexes. So 0 to events length -1. Okay? So it could be 0 to 6, or it could be 1 to 7. Doesn't really matter. So you're basically looking for each event in the array. You get another mark just attempting selection, where we're comparing date against date input against a date in the array to see if it's there. And then we're adding the length from the array to the total if the dates actually match. That would be another mark. And then you'll get 1 mark just for doing that, for outputting the total and the date in that message in the end. Okay? So they will only give the output mark if the attempt is made to calculate the total within the algorithm. So if you were to just have that, you wouldn't actually get that output mark. So you'd have to do this bit, for example, and this bit to get the marks. Okay? And let's see how much we got more to go. And that, ladies and gentlemen, is the end of that god-awful 2023 paper, GCSE Computer Science, Paper 2, OCR Spec 2023. And that is that, ladies and gentlemen. So I've taken you through this walkthrough. So if you like this video, please remember to click that like and subscribe button and share this video far and wide. And put a comment in the link below and tell me how much you've enjoyed this video. Especially those who sat this exam in 2023, who found it awful. But with this paper just come out, hot off the press, this is getting uploaded. So, excellent idea. So hopefully this paper won't be as bad as this one again. Thank you for watching, and I look forward to seeing you on the next video. Thank you very much for watching. Bye for now. So please be sure to hit that like, and please also remember to hit that subscribe button. And another way to subscribe is to just click on this link, which is below each video I place. And if you like my content and you want to find out more about what I do, I've also got an online course called Introduction to Computer Systems on the Udemy website. So you just need to click on it, and there we go. So this is my online course, Introduction to Computer Systems. So this is the landing page for that course. So in it, you will learn. So these are some of the things we'll learn, like explaining the role of the central processing unit, describe the components of the CPU, provide an introduction to assembly language, which is low-level programming, explain the factors that affect the performance of the central processing unit, and I've also put in another bit that I'm interested in, the physics of overclocking the CPU, which may me develop an interest in electronics and also physics. So there's a lot more to it than even we realized. So this is the course content. So you've got computer systems, so I'm introducing you to it. Then I'm going into the different forms of architecture and assembly language. Then I'm going into the factors that affect it and the physics of overclocking the CPU. And then I'm going into logic, so combinational logic systems, making the logic gates, sequential logic systems, semiconductors. Then I go into all things binary, where we introduce you to number systems, all the way down to doing binary and sound, images and text. And then finally we got input and output devices and the different forms of storage, so that's where memory will come in. And then my assessment is basically one big quiz of 30 questions. So you don't need any knowledge to do this course. All you need is a computer with stable internet connection. So that's all you really need there. And why you should do the course? Well, wherever I don't know, I'll go out and learn it. So the way my brain is wired is I'm on the autism spectrum. So it will be an asset in helping you get through the online courses that we provide. So we understand how to explain things in simple terms due to my teaching background. So you could think of us as a real-life version of, say, a Sheldon Cooper from Big Bang Theory, minus the rudeness, or a C-3PO, but without the glitches. So I'm on the autism spectrum, so we're on the autism spectrum and have a rough idea on how to talk to them and relate to them. And my teaching style is that style I've crafted and one that works in a way that some people don't get if they only had tuition in the classroom or just want to study the subject a lot more. So this course provides you with the opportunity to go further than you would in the subject that you want to pursue. So those are some of the reasons why you should consider buying this online course, because once you buy it, it's yours for a lifetime. For some of my videos, I will go through programming tasks. So if you want to do these yourself, I have put a REPL link below on my programming videos. So you just click on REPL, and this is what you need if you haven't signed up at all. So you just click sign up. If you've got an account, you just click login, and once you've logged in or signed up, this is the page that will appear. So if I was to log in right now, this is the page, so this will appear. So that will be the page there. And in addition to all that, I am also a private tutor where I offer my private tutoring services specializing in ICT and computer science. And I look forward for you coming to me for lessons. Goodbye for now.